Okay, Mark, thank you for the introduction, and I promise I'll make this very quick, so everybody can go to lunch. So my name is Andreia. I'm from Portugal, but I'm here doing a PhD in Auckland, New Zealand. And Mark invited me to talk about haptic placement, which I have published work on this, but I'm really excited to talk about this because it's the kind of the factor that kind of wasted 2 years of research for me. So a lot of failed user studies because I didn't consider this important design factor. So what I built in my research is mostly creating these haptic devices that distort the way we read our body, and then use that to modulate emotion, motor control, and also empathy, interpersonal empathy. So I learned the hard way that where you place the haptic device, no matter the type, if it's thermal, vibrotactile, whatever it is a very, very important decision. So I'll go through, I'll give you a roadmap of what I think people should consider when they are working on-body haptics, especially if it's affective haptics that are meant to communicate or to stimulate any type of emotion. So let's start thinking of the same modality, right? Something that we all have experience with, a vibrotactile notification system. And what if I told you that the exact same motor, same parameters, same haptic signal, the way your body responds to these three signals is very different. And why is it different? Well, because the different parts of our body have different receptors, sensitivity, and even emotional interpretation. So on this presentation, I'm going to give you a roadmap through 3 questions that I usually use when starting to build any haptic device. So the first one is, can they feel it? The second one is, what will it make them feel? And the third one is, can they wear it? So starting with, can they feel it? This seems the most straightforward, but actually it goes a bit into biology. So give me a minute to go into this very technical terms on biology, but I promise it pays off. So we have 2 types of skin. So we have something called the glabrous skin, which is the palms and the fingertips, which are very high resolution. So we have high sensitivity. We can very quickly understand that we're receiving a signal, and we can very quickly react to these signals. Then we have the hairy skin, which is almost everywhere else in the body, which is very low resolution, but it's got this special wiring that is called the CT efferents. So this is the secret ingredient to what makes haptics feel pleasant or unpleasant. Hold that phrase on pleasant touch. We'll go back to it later. So here your precise skin and your emotional skin are kind of different skins in different places of the body. So how do we know this? So on this image you can see on the left, some researchers created this robot, a petting machine of sorts that is petting your forearm. And they put a bunch of electrodes on your skin to understand when the fibers of the skin fire. So like when the touch sensors in our body get triggered. And what they found was that these fibers match how pleasant people say the haptics feel. And the hairy haptics and the non-hairy haptics are very, very different. So this is why there's so many works that will be on petting. It's kind of weird, but I think because it's the state of the art, a lot of people focus on this petting haptics, and there's a bunch of work that's proven that the hairy parts feel that this petting is more pleasant. Right. So the way these fibers are touch sensors, fire control how much of a signal we can feel. So different body parts through different contexts have different detection rates. So always consider the context in which the feedback will be triggered. So as you can see on this plot, something that is pretty much understood is for example, the thighs are pretty bad for placing haptic feedback because we have less tactile receptors there. Also, something that is important to consider with the thighs and other parts of the body is that if you are being mindful of designing for different body parts and different sexes and different lifestyles, is that muscle and fat kind of subdue vibrotactile feedback. So that's why the thighs are usually the worst place to place a vibrotactile or even a thermal feedback. So as you can see on this plot, the wrist is understood to be the safe place for some more fine-grained feedback. So on this work, they were building a wearable vibrotactile device for first responders. So they wanted to be able to vibrate to let the first responders know when they were walking into danger. And for this context, it's really important that they react fast to the vibration and they feel it very quickly. So they chose a bunch of different body parts and placed this vibrotactile that I'm pretty sure was an audio transducer. So they are replaying an audio on the skin, and the skin is vibrating with the different frequencies of the audio. And they saw that, for example, the waist was pretty good for this context because it is a place where the fat of the body isn't moving around as much when they are walking or running. And so the body doesn't tune out the vibrations that are given to the waist. But as you can see, the fat and muscle are different between people, between sexes, so the sensitivity is kind of not a universal thing. Then on another study, they were also exploring the perceivability of haptic feedback, and they put it on a bunch of different pieces of clothes or even in contact with the skin. And as you can see, the task that the people are doing matters a lot in evaluating these systems. Like I said, movement of body, the fat, the limbs are moving. Our brain has a way to tune out that movement, which makes feedback on very high movement kind of pointless. And then you have also the cognitive load, which is the more resources our brain allocates to different tasks, the less resources it has for the perceptual model. So if you are very focused on a task, or if you're in high effort, you will have lower detection rates than if you're sitting down static. And that's pretty much universal. So the moment that people move, a lot of body parts kind of lose sensitivity. So if your demo is really amazing when someone is sitting, but then when they stand up, it doesn't work, this is probably why. So when you're testing, test the person standing, walking, running, whatever it is, not just at the table. The thing that I do need to talk about when I talk about can they feel it, it's probably not a problem that you have when you're designing a prototype for a laboratory setting where the person is going to try for 20 seconds and then never again. But is a glooming problem in haptic research that is habituation. So it's kind of a scary part of haptic research. So we as a species are really adaptable. And when we are presented with a new stimuli, we have very primitive responses. But the more contact we have with these devices, the brain kind of settles into it and the responses change. They are shaped day to day. And this can be a good thing. For example, for this project, the Mimic project, they put a ankle bracelet with a vibration motor. And the idea was that it was two partners. And when one of the partner was moving, you would give a vibration to the other person, which is kind of annoying, and you can see on the plots, people found it pretty annoying in the beginning, but as the days went by, it kind of became part of their lives, and their responses changed a lot, and their perspective on the device. So that was on can they feel it? Now, what will it make them feel? And this is the parts that I spend most time on my research. So assume someone can feel your feedback very accurately. Now, what physiological reactions or emotions does this spot create? So at this, on this question, I usually divide it on 3 different fields. So we have the affective touch, the social meaning, and the interoception. So starting with the easy one, the affective touch, that's like the petting machines. Like I said, there's a lot of petting machines on the forearm. So these defective touch fields try to replicate the touch of someone or something or a robot. And a lot of these devices are like this one. They put, for example, a little furry parts on a petting machine, and it's just caressing your arm. And they found this was really good to fire, to increase the firing of the hairy parts of your body. The arm is usually chosen because it's a bit less intrusive place where someone could be petting you, I guess. I don't know. I don't think petting is that popular. But we have then this other work that is the breeze. So they created this haptic device that is sensing your breath, and your partner also has the same device. And this, as it senses your breath, it kind of gives audio of your breath to the other person, so on audio transducer, and the chest of the other person is vibrating as you breathe. And this is another in-body experience where they chose the chest because it's kind of where we relate the movement of the diaphragm and breathing. And that leads us to the social meaning part of it. And the thing about designing wearables, especially when touch is supposed to represent the touch of someone else or of a foreign instrument or a foreign system or avatar, AI agent, whatever it is that the location where you place it, it's super important on this mitigation of social meaning. This thought of social meaning should be probably the first step. And here you can see on this plot, which is kind of a scary plot, the different zones and the ones that are seen more or less appropriate to touch, depending on the person that is touching them. If you check the strangers, for example, even the forearm is darker red. So the brushing, petting machines, even for strangers, would be kind of passing a red line. So the different social connections that people have mean different thresholds for each location. And this, when you're creating a device, if anyone is creating a device where the avatar is touching you, keep this in mind, where people actually like to be touched for when they don't have that intimacy with the identity that is touching them. So interception. So this is the one that my research is mostly about. So let me indulge a bit on this. So I'm going to just tell you very quickly what interception is. So the idea is that our body reacts to external stimuli through the 5 senses, and this process is called exteroception. Then the stimuli are then processed by the brain, and the output is an emotion. And that emotion usually results on physical reactions like increased heart rate, increased breathing rate, whatever it is. These signals turn into something that we're going to call somatic markers. And the somatic markers are just like memories that your body can relate to a specific situation, a specific context. So our body signals then enter this loop where you're sensing that your heart's rate is beating, like your heart is beating really fast. And because it's breathing, because it's beating really fast, then it creates a stimuli of nervousness. So it's a loop that is really hard to get out of. And the easiest way to understand this is the concept, let's say, heart rate. When we're anxious, our heart increases, and then when we physically feel our pulse, our brain tries to respond to, what does this mean? It goes to this library of when our heart has increased before and finds a situation where, for example, this is an example that I usually use, that, for example, Mark asked me to see a paper draft, and I didn't have a paper draft because I hadn't started writing it, so my heart increased. So when my heart increased, Mark, right? That never happens. So when my heart increased, it kind of, the brain goes to this memory, and it's like, oh, if it's increasing, then it's a bad memory. It's like almost, we use the word trauma, but this is like physiological memories that are also revolve around what we call trauma. So a lot of works in haptics try to create systems that kind of change how we read our body, so our body doesn't do this cycle. And On my WIS paper from 2024, we did a fake heartbeat experiment where we had an audio transducer repeating a fake heartbeat that the person didn't know it was a fake heartbeat. And we tried different body parts to see how it affected people's perception of their own emotional state, if we could change their physiology by intervening in this internal loop. And what we found was that, for example, for the subjective experience, and this is, if you try this, you probably will find that nobody likes to have stuff touching the neck. So if you place something on the neck, it probably is not going to go well. We had one participant that was really into it, but I think that's like an outlier. So I would try to avoid anything on the neck. And we found that the chest is usually where the people expect to feel a heartbeat. So we find this metric of harmony is how, if it makes sense to feel this vibration on this context, on this place on my body. And the chest is usually what we associate with heartbeat. So the problem is that this should have been the end of it, right? The subjective experience. The problem is that our objective was to change physiology, not to create this embodied experience that people really liked. And what we saw is that actually the ankle was really good. Because when we talk about the effects on physiology, it's not about it becomes a more subconscious experience. And even though people do not expect to feel their pulse on the ankle, even though it's a pulse point, so there is a pulse there, when people are sitting down, this fake heartbeat kind of work better. If we had tried this while people were walking, probably we would have different results. So that's future work. I don't have time on my PhD to do that. So the lesson here is that your device might have consequences for people's own awareness, especially when they represent external data from a system or from someone else. And the last question is, can they wear it? And this one is pretty easy to respond because how people accept wearing a device usually is correlated to how they are perceived in society. So do you want to wear a weird device on your face? Yes, but if for example, the Google glasses that came out, I don't know if anyone remembers the Google glasses, they were very, like if you've seen someone on the street with them, you know it's like a 1% geek, like top geek state. And it would, even if you like the device, you wouldn't wear it in the streets to not be perceived as that. So on this paper, they mapped out all the locations that people kind of accept to have stuff put on their body. And this is usually, the chest, ears, forearms, wrist, hands. I think those are all safe because we already use a lot of devices on those places. And then there are places where people feel less comfortable. And I think, there's a huge gap because we don't ever see like butt haptics. And I think somebody should explore that haptic gap. But as you can see here below the waist, it's pretty much dead on arrival for a daily device. And for a device like mine, for my WIS projects, this trade-off needed to be considered. So we probably would have to choose something that has less effect on physiology, but then is actually something that we can put on the real world, not just a laboratory setting. So just to finalize, I'm going to show some cool haptic devices that are put on weird places, just so I can end on an inspiring note, and everybody can go to lunch. I'll show you the first one. So this one is from University of Chicago, Professor Pedro Lopez, and what they did was they put like a nose clip that has Peltier's thermal actuator in the nose. And the idea is that if you give cold feedback to people, they will perceive their breath to be better and deeper. And you know how during winter it feels like it's easier to breathe. That was kind of the idea. And they were exploring haptic devices that could help you feel like you're breathing better when you were wearing, for example, a mask during COVID. So they put this device below the mask, and they saw that it actually changed people's perception of their breathing quality a lot. Then I can show you the next one. This one is weird, but it's the Kinsinger. So it's like a keys simulation haptic device where two partners, in remote settings would have this device they would bring with them, and they could kiss this device on the mouth, and you would kind of sense it and create an actuation on the other device. If you remember the situation, the plot where it was the acceptability by relationship, the partner relationship was kind of like you can do whatever you want in any body part. So I think this is the only setting where you can kind of actuate the mouth like that. So the next one, there's no video, but this is like a pretty famous one. It's called the mood wings. So they were using people's electrodermal activity, so how the conductivity of your hands, the skin conductivity, to kind of simulate this butterfly moving their wings. And the objective was to use this as an accessory where you could be very aware of your stress in real time, so you could adapt and self-regulate. Then there's a lot of works on this that is like to simulate body shivers, spine shivers. And on this paper in specific, they use two Peltier elements to try to give you the illusion that there's a shiver coming down your spine. And what they found, and their objective actually, was to give people, so you were watching a movie and they found if they simulated a shiver in your spine, that people would report it as enjoying the film more, and would, in music the same way. So this simulated shivers would give people the perception, they would read their simulated shivers and think, oh, I really like this film, or I really like this sound. And then the last one that was actually made here in Auckland is the tickle foot, which it's pretty self-explanatory. So they created this haptic device to tickle your foot. I think it's kind of evil, but their objective was to find what parts of your foot were better to tickle people. Again, very evil, I think. But what they found was that, let me go a bit further, is that if they change the point of the actuator, they could turn something that was ticklish and kind of make a foot massage. I think that was just them covering their tracks to not say that, we're trying to find the optimized tickle machine. So yeah, that's all I have to say. I think while you're building your projects, I think consider the place where you put them, explore, but make sure that people's boundaries are being respected and the social meaning is being respected. And yeah, if you have any question, I'm sure we're all going to dinner to lunch soon. So